University Winter School session. And today we are pleased to have Jacopo Tagliabue from Goyal and Savin Goyal from Out of Bounds. As you know, the series of sessions we've been having since summer of 2020, since COVID hit, we have kind of extended that for the past year and a half or so, and we have more than 50 speakers who have presented various topics of interest, primarily for the machine learning community, as we kind of embark on taking all these interesting ideas and then developing models and then productionizing models. And the whole theme of model risk management and productionizing machine learning has been what we've been discussing over the past year and a half or so. And in today's session, I wanted to invite Jacopo and Savin, who have significant experience building production-grade pipelines in their respective companies in the past. So Savin and I got to know each other when Savin was at Netflix, and he was also presented to my students at Northeastern University in the big data class, sharing his knowledge and experience about how big data pipelines and machine learning pipelines are built within Netflix. And that project, which was Metaflow, is now a part of his startup. And Savin, I'll let you talk more about it in a minute. And then Jacopo and I, we got to know each other, and then got to know a lot about what Goyal does and how search is done within Goyal, but also in the context of building machine learning pipelines, how are the various challenges he's seeing, and how has he been building tools to support the various use cases he's been working with in his company. And along the way, we kind of we're also interested to kind of explore, how do we document these models? How do we kind of make sure that we share what we've been building with all the folks within the organization, which becomes a practical challenge, especially because the developers have a lot of context on what is being built, but then it needs to be shared with the rest of the world. And it also has to be live and up to date. So he has been working on putting together a framework, which is also open source. And he presented with his team at NeurIPS, right? So last year at the data, and we thought we'll kind of get a flavor for his work there too. Formal introductions to both. Jacopo, he's educated in several acronyms across the globe: UNISR, SFI, and MIT. Was the co-founder of Tuso, an AI company acquired by Goyal in 2019. And when he's not building products, he teaches ML systems at NYU and explores topics at the intersection of language, reasoning, and learning, with research work presented at NACL, Rexus, ACL, SIG-IR. In previous lives, he managed to get a PhD, do sciencey things for a pro basketball team. I want to hear about that some of the time, Jacopo, and simulate a pre-Columbian civilization. Oh my goodness, that's very interesting. And then Savin is the co-founder of and CTO of Out of Bounds, where he focuses on building generalizable infrastructure to accelerate the adoption and impact of ML in enterprises. Previously, he was at Netflix, where he built Metaflow, a popular OSS ML platform. In his previous life, he obtained a bachelor's degree in computer science from IIT Delhi. So welcome, Jacopo, and welcome, Savin. It's always a pleasure to hear from you, and especially when you're building out all these cool systems. We really want to see what's under the hood, literally. So Savin, take it away. We'll spend the next 40 minutes or so, getting an introduction to the framework Metaflow, and also looking at this notion of documentation using different kinds of cards. And then we will kind of open up to Q&A. And for people in the audience, if you have any questions, please type it in the chat window, and we will answer them along the way or later in the program. But also, as you know, Quant University has partnered with Premier to host an artificial intelligence risk management program, which was launched in January. So if you're interested in it, go to the QU Winter School 2022.splashthat.com, where you'll find information about the courses we are offering, and also the upcoming lecture series. We have had the pleasure of working with professionals from the industry, academics and also from various banks. Next week is going to be a very interesting session with Andrea Brennan from In-Q-Tel, and they've been doing some work on machine learning assurance. And it's going to be on Friday next week at 12 o'clock. And I will send out a notification on that too as soon as possible. And we will continue the conversation with Jacob and others over the next few weeks. So welcome again. And I will give you the stage. Savin, please take it away.
Thanks, Sri. Let me just quickly share my screen. Okay, is my screen?
Yes.
Okay, awesome. Yeah, excited to be here. Thanks for having us, Sri. Both Jacopo and I, we have spent a majority of our career building machine learning applications. And in this talk, we would like to share some of our observations, some of the tools that we have built to sort of like address some of the pain points that we observed. And hopefully there'll be enough of takeaways for a healthy discussion afterwards. So let me sort of like, I'm pretty sure like most of the people in the audience, they would have toyed with the idea of building a machine learning application, either as a side project or as part of their professional work. And by and large, most data scientists, the kind of life cycle that they observe when they have to solve any sort of like business problem through machine learning, it's pretty similar, so to speak, right? Like a data scientist, usually they'll sort of like start off with some business problem. Usually it'll be some metric that they have been asked to optimize, or some metric that they are asked to sort of like predict for. Think about the scenario of, let's say, for example, Netflix, where a data scientist may be tasked with predicting what could be the lifetime value of any single individual who is signing up for Netflix membership. And that can come in really handy when it comes to figuring out that what kind of affordances that subscriber should be provided. Should we sort of like offer them any discounts? Should we sort of like proactively reach out to them via customer service to make sure that they do not churn away? And usually when a data scientist is presented with such kind of business problem, they'll usually sort of like, spin up some kind of IDE, whether it's sort of like a Jupyter notebook, if they are sort of like in the Python universe, maybe it's a PyCharm IDE, maybe if they are using R, then maybe the RStudio interface. And that sort of like is their authoring experience that allows them to access their data sets, do some exploratory data analysis, to really understand what is the data set that they are playing with, what are the possibilities that are in front of them. And now over the last sort of like 5 to 10 years, we are sort of like, in this amazing point of time where there's excellent activity happening in the open source universe when it comes to machine learning frameworks, right? You can sort of like very easily do a pip install TensorFlow, pip install PyTorch, get access to the latest and greatest of research. It's also evolving very rapidly. You'll sort of like get to see some kind of innovation being made in the academia, and then very soon you would have access to the actual code that can allow you to play with that innovation. So things have rapidly changed over the last 10 years. But now when it comes to real world enterprise machine learning, you have to sort of like step a little bit beyond that, right? In the case of Netflix, for example, all the data is stored in a data layer, which is built on top of S3. So now a data scientist has to figure out that, okay, like I have this notebook and I have access to the latest and greatest of machine learning frameworks, but then how do I access this data, this humongous amount of data, and move it to my notebook, which could either be sort of like hosted on my laptop, or it could be hosted on some sort of a cloud computing environment. And there's some amount of work, some amount of knowledge of data engineering that is then sort of like expected off of this data scientist. But then it's not just only about accessing that data, right? You have to then massage that data in the right format so that then you can slice and dice it. So there is some amount of data transformation, some ETL steps that you need to sort of like take into account. Very often, this could be simple feature engineering tasks where you want to sort of like mutate your data to collect sort of like features that then you can passed to your model training code. Very often it could be just some exploratory analysis that you're doing to better understand the distribution of data. But then you're sort of like now slowly sort of like leaving the realm of machine learning and entering the realm of data engineering per se. And all of that is sort of like, good and fine. But then what happens is that, let's say, now you have some model training process, you're able to sort of like interface with your data warehouse, and you have something that sort of like just about works on your laptop. Very soon you would realize that, okay, the amount of data that you are playing with, that sort of like suddenly goes up. In the case of Netflix, for example, we were dealing with data for like 200 million subscribers. And for certain business problems, that can be a not so insignificant size of data that may not fit into your laptop's resources, for example. Or maybe for certain use cases, you may want to train your model on top of GPUs or on top of certain resources that are, again, not readily available on a laptop. And maybe you want to sort of like get access to some cloud computing resource. And then the question sort of like then pops up to the data scientist that, okay, how do I sort of like lift and shift the work that I've been doing on my laptop into the cloud? And all of a sudden, a data scientist many times is expected to sort of like then jump into the realm of systems engineering, understand what is Kubernetes, what is Docker, how do I containerize my work and shift it into the cloud, and not just like shift it into the cloud, but then observe the logs, get access to the results that my cloud computing environment offered back to my laptop or to some other place, so that then sort of like, this model can be deployed or this model can be introspected. There could be other scenarios, other issues as well, like, for example, at Netflix, for many of the content distribution networking related problems, Netflix had to train a model that was unique for a language, unique for a geography. And that can suddenly blow up, if, let's say, your business sort of like operates in 200 different countries, and each country on an average speaks like 3 different languages. All of a sudden you are training 600 models, and each model training step may have significant resource requirements as well. So now how do you sort of like distribute this compute? Again, like, this is sort of like has less to do with machine learning itself, but more to do with systems engineering. And at that point, a data scientist or a machine learning engineer has to necessarily wear that software engineering hat. And then, of course, like, once you sort of like do it once, then there is a question that, okay, now I need to train my model repeatedly, maybe every single time my data set changes, or every single day I need to sort of like train or retrain newer models that then can be sort of like pushed into production. So how do I sort of like schedule these asynchronous runs? What is that sort of like infrastructure that allows me to do that? And how do I integrate with that? That becomes a big question when it comes to productionizing the model. But then, of course, once you have sort of like gone through all the steps, and you have sort of like figured out that, okay, like, this is the way I can reliably retrain or generate a model every once in a while or at a particular cadence, the question comes that, okay, how do I use this model, right? I mean, if you train models, but you're never able to use those models, you're never able to actually deploy those models, then what's the point of even training those in the first place? And again, there are like many solutions that are out there. People deploy models for real-time inferencing as microservices. You can sort of like deploy a simple Python Flask app. You can deploy a Shiny dashboard which can rely on your model. You can have a very sophisticated CI/CD process as well for deploying these models. You may want to integrate with a bunch of different model monitoring solutions, and there are like a bunch of vendors who are selling those as well. But then that again requires a lot of engineering work, not only to sort of like spin up these hosted models, but also on an ongoing basis to monitor the quality of results as well as the uptime SLAs that we have promised for these services. And that again sort of like requires a lot of software engineering background, a lot of engineering rigor. And then at the end of this, you're able to sort of like power an internal dashboard or an end user experience, right? Like, I mean, for example, let's say if somebody had to ship a new algorithm for Netflix recommendations, they would have to go through all of these steps before that experiment can go live, and they can see and measure for real how their models are behaving in real life. And that requires sort of like a good amount of expertise in machine learning, but also a fairly heavy amount of expertise in software engineering as well, that not very many data scientists may be well equipped to handle. And that can very often cause a loss of productivity. Organizations, when they invest in data science teams, they want them to sort of like focus unequivocally on the data science elements of it, because that's inherently what data scientists like to do. But then the fact that to deploy a model in production also requires significant engineering effort, that usually limits the number of models, the amount of iteration and exploration a data scientist can do. And that was the problem that we were running into at Netflix over and over again. And the goal was that, okay, can we sort of like build a platform that can take care of all of these engineering concerns, so that the data scientist up top, they can focus on machine learning concerns that they enjoy very much doing. Now, all of this sort of like, is still good. I mean, there are sort of like traditional software engineering platforms as well that sort of like, promise to solve similar problems. But then what sort of like makes machine learning rather unique is that once you have deployed a model, one of two things can happen. The one thing that can happen is that maybe sort of like your model fails to perform as expected. When sort of like your model meets the reality, it may not sort of like turn out to be so promising. And at that point, you would have wished that, this entire life cycle of coming up with an idea, prototyping it, and shipping that model into production, if only that could have happened far more quickly, then you would have saved a lot of time, the time that you sort of like ended up spending on an idea that did not pan out. The other sort of like thing that can happen is that maybe sort of like, your business stakeholders are super happy with your results. And at that point, there would be an added focus on shipping more models, more higher quality models. Maybe there are more data scientists who get added onto your team. And then you would sort of like, be in a scenario where you would have hope that, okay, all the work that I did, maybe sort of like, I had done it so that it wasn't sort of like too much prototypey. Because as it happens, if let's say something turns out to be a lot more promising, then there isn't usually a lot of time that's afforded to the data scientist, the original engineering team, to go back in time and actually sort of like write code in a manner such that it doesn't look like a prototype and is sort of like production quality. But now, if let's say, the models that you ship, they sort of like, lead to significant user retention. Now you're at a spot where your business stakeholders are coming back and they are essentially now demanding more and more models. So you have to essentially build on top of what you have already shipped. And you would wish that, like what you had built, the foundations were strong enough so that the next thing that you're building on top of that can sort of like be equally stable. So that's essentially, like the problems that we were trying to solve. So this is sort of like, in many ways capturing the data science stack. As a data scientist, you have to sort of like, by design, or you're in many ways forced these days to care about sort of like the data warehouse, how you're interacting with the data, the compute resources that are afforded to you. Many times data scientists are exposed to the complexities of underlying compute substrates, whether it's like Kubernetes or some in-house compute system. How do I sort of like, think about workflow orchestration, whether, like, should I be sort of like a ninja when it comes to like writing workflows in Airflow or step functions or Flight or Daxter or Prefect? How do I think about like architecting all of this code so that, I'm capturing the right amount of logs, I'm taking care of experimentation management, I'm taking care of reproducibility, I'm writing code in a manner such that other data scientists can jump into the project and they can sort of like collaborate without sort of like, hindering my own progress. There's a bunch of software engineering rigor that's involved. And again, like we're not even sort of like, as of yet talking about like all the concerns around model operations or model ops, which is sort of like super popular term these days. And then only at the top of that are the concerns around model development. That, okay, how do I actually formulate this business problem into a mathematical model? What is the data set that I use? How do I massage, or like what are the features that I need to use in terms of training my model? What is the training library that I use? Like all of those are up top in this data science stack. And ideally, from a data scientist's point of view, they would want to concern themselves just with model development, and they would want sort of like all the underlying concerns taken care of for them. But that's not where the reality is at. And that was essentially sort of like, the goal that my team had, that can we essentially build a tool, so what we built, we called it Metaflow, where we can provide sort of like this opinionated layer across sort of like all of these different layers of the data science stack, so that our users, the data scientists, they can essentially focus their entire energy on building the very best models, while we can take care of sort of like all the underlying engineering issues that they run into every single day. Let me very quickly sort of like, walk you through, like give you a very high level overview of the programming model that Metaflow exposes. And then Jacopo can sort of like, will take care of going through an excellent sort of like addition to Metaflow and how it enabled data scientists at his organization to be far more productive. So with Metaflow, we essentially espouse that natural way of expressing your machine learning training code is via a workflow, via a pipeline. It could very simply be sort of like, a bunch of linear steps where in one step you are essentially interacting with a data warehouse, and you are pulling some data from that data warehouse. Then you may be sort of like in another step generating some features out of it. Then maybe you may have multiple steps that are running in parallel that are training multiple different variants of the model on top of the same data set. And then in a subsequent step, you may want to figure out what is the best performing model. And then you are, let's say, writing that model somewhere so that it can be picked up by some other process. Now, let's say, in this particular example, let's start with sort of like a very simple ML script. Let's say you are training a random forest model. So this fit model step does exactly that. It launches a Spark SQL job, and it sort of like gets you the data as a pandas data frame. And then in the transform features step, you are essentially getting some features out of this data frame. And then you are estimating that model, and you are pickling and storing that model in a file. And if you execute that fit model, those would be the steps that would essentially happen. Now, what Metaflow introduces is it introduces a bunch of decorators. So you can essentially very easily refactor your code into a workflow. So in this particular example, maybe sort of like, our workflow has two steps. So the first step is build features, and then the next step is the fit model step. And the build feature step, it's responsible for talking to your data warehouse and getting you the features. And the fit model step is then just like generating those, like fitting the model on top of those features. And you can very easily just denote at step decorator to define that, okay, build features and fit model, they are the nodes in my graph. And then you can see sort of like the last line in the build features code function is self.next fit model. And that's how you're essentially specifying the edge to the next step. And you can essentially just execute it like any other script, and Metaflow will execute that script for you, and it will associate sort of like a unique run ID to that script, so that every single time you execute, there is an execution log that's already maintained for you by default, and it will essentially keep track of all the metadata that you need. So you can go back in time and you can look back and say that, hey, like I want to check out the work that I did 3 months ago, and can you sort of like, give me the code that executed and all the intermediate state for that. And Metaflow will very easily sort of like provide you that information. And in addition to the metadata that it stores, anything that you assign to the self class instance variable over here, like for example, the transform features step generates features and target. And then in the fit model step, we are assigning estimator to self.model. Anything that's assigned to self, that gets stored in perpetuity for you. So you can go back in time and, I can, for example, say that, hey, I want to actually identify the model that Jacopo trained 4 months ago. Can you give me that model? And Metaflow will very easily sort of like provide you access to that. And you can use that inside a notebook as well. So in this particular case, for example, I may have a flow called training flow, and I want access to the model that was generated as part of its latest execution. So I can very simply just say that, okay, like for this flow, for the latest run, can you give me the model? And I have access to that model in basically any Python process, whether it's a notebook or any other sort of like application that's running. And you can imagine many different use cases for it, right? Like you can have a workflow that's training a model, and then you can have a microservice that's serving that model, and that microservice can access that model through this very small, tiny snippet of code. And every single execution, as I mentioned, it's version and namespaced. So I can access Jacopo's latest run, I can access my own latest run, I can access everybody's latest run, I can tag those runs as well, so that I can make sure that I'm not stepping over anybody else when it comes to any of these executions. I can tag sort of like a specific execution as a production run, while I can tag other executions as sort of like staging runs or development runs. And then my production microservice can subset on the models that are tagged production, so that it's only loading the latest production run and not really sort of like worrying itself with like any other development runs that anybody else on the team may be running. So all of those functionalities are enabled by Metaflow. And because we are essentially storing the intermediate state, you can essentially restart from any step. You could sort of like, imagine a workflow where you have a step where you are generating some features, but then you are training a model in the next step. And for some reason, your model training code is failing. And what you can do is you can essentially just change or edit your code for the model training step, and you can resume your workflow from the previous step, so that you can essentially memorize the compute that had happened in the past. And that essentially allows you to sort of like iterate rather quickly when developing these workflows. And you don't have to sort of like worry about like how to sort of like checkpoint your workflow by yourself. Metaflow essentially takes care of that for you. And all of that is sort of like good and fine, but then there are also many ML specific functionality. Like one of the more sort of like common use cases for data scientists is that they essentially want to run the exact same model training code against a bunch of different parameters and train multiple different models and then identify what is sort of like the best performing model. And Metaflow allows you to sort of like do that in a very simple and straightforward way. In this particular example, rather than doing self.next to sort of like this fit elastic net function, I'm also passing in this variable for each. And you can see that this for each variable elastic net parameters, it's essentially a list. And what Metaflow will do is it will essentially launch as many instances of fit elastic net step as is the cardinality of the elastic net parameters iterator. And it will essentially handle that parallel execution on your behalf. You can imagine, like at Netflix, we had like users who would sort of like, iterate over thousands of parameters in one go. And what Metaflow will do is it will essentially allow them to get access to, supercomputer style resources very simply in a very straightforward manner. And the way it would do that is you could very simply sort of like, just offload compute to the cloud. For example, this fit model step maybe sort of like, it needs access to 16 CPUs. My laptop does not have access to that. So I could just define this at resources CPU equals 16, or maybe, like I need access to a GPU. So I could define GPU equals 4 and it will run on an instance with 4 GPUs. And I do not have to worry about how to containerize this particular step, how to ensure that, the inputs to this step are readily available on the cloud instance, as well as I can access the outputs of the step. All of that work is automatically done for me through Metaflow. And if I pair it with the for each notion that we have, all of a sudden you can have users who are launching, let's say, 1,000 unique instances, 10,000 unique instances, each of them running on a dedicated EC2 or like a dedicated Docker container on your EC2 pool of instances in the cloud, for example. And that sort of like massive results in massive productivity gains for your users, because now offloading compute to the cloud is sort of like, it's as easy as sort of like, running something on your laptop. So in this particular example, you're still executing Metaflow as you would before, but you can see in this sort of like execution log, the task is essentially then submitted to your cloud computing environment, and it's executed over there. And then Metaflow will sort of like just execute your code. And then you can also sort of like mix and match different steps. So you can have a scenario where your feature engineering step runs on an instance with a high amount of memory configured, then your model training step runs on a GPU instance, then let's say a step where you are sort of like just comparing models, maybe just runs on your laptop locally. And that way you can sort of like have optimal usage of your compute resources, driving down costs and driving up utilization. But another sort of like, big issue that was biting our users quite significantly was this issue of dependencies. Now, as I mentioned, right, like the open source universe of training frameworks, it's a fast moving universe. And we had users who wanted to be sort of like, always on the bleeding edge of these dependencies. They wanted sort of like, the nightly releases of TensorFlow. Well, there were certain other projects which were very critical for us, and we wanted to guarantee stability. And for them, it was rather important that they were sort of like, on a stable version of, let's say, like PyTorch. And now we were sort of like, in a situation where different data scientists, or even sort of like single data scientists for different projects, they wanted access to different libraries. And of course, one thing that we could have done is we could have sort of like created an ecosystem of many different Docker containers. But then maintaining and managing those different Docker containers by ourselves wouldn't really have proven out to be scalable. So what we allow people to do is they can essentially very easily specify the dependencies that they want for any given step. And they can also have different dependencies for different steps. And we will create this environment and we'll lock this environment. We'll essentially provide the guarantee that at any time in the future, even if let's say scikit-learn 24.1 disappears from Conda or from pip, we are still able to rehydrate this environment on behalf of our user and provide them this hermetically sealed execution environment that they can lift and shift and execute anywhere, whether it's on their laptop or whether it's somewhere in their cloud environment. And that then allows our data scientists to very freely experiment. They can sort of like try out TensorFlow, some version of TensorFlow. If let's say, they want to get access to a new version of TensorFlow, they can just like very simply update that dependency version and they have access to the latest and the greatest without sort of like worrying about talking to a platform team to provision sort of like a newer Docker image that has the required set of dependencies for them. Then, as I mentioned before as well, right, like all of this is good and fine as you're sort of like developing your training workflows. But then the big question that sort of like pops up is, okay, how do I run this asynchronously? How do I ensure that, every single day, whenever there is a new data set, new input data set that's available, there's some sort of like asynchronous workflow orchestrator that can execute my workflows. And I do not have to worry about that. And there are many different workflow orchestrators that exist in the commercial domain as well as in the open source domain that are rather popular. AWS Step Functions is one, Airflow is another, Argo is another one if you're sort of like, Kubernetes native. And all of these workflow orchestrators, they are sort of like very production grade workflow orchestrators. They are usually also running data engineering pipelines for you. And now the good thing is that with Metaflow, you have already declared a DAG, a directed acyclic graph. And all of these workflow orchestrators, they're also responsible for executing a directed acyclic graph. But of course, their programming model could be very different. And the functionality that they provide is also very different than what Metaflow provides. But then within Metaflow, we can essentially compile the code that you have written into a format that, Step Functions, Airflow, or Argo understands, so that you can essentially offload your workflow on top of these workflow orchestrators and execute them as a native workflow within their universe. And that means that, if you have integrations with PagerDuty or if you have integrations with like other scheduling policies, then your Metaflow workflows are now part of your normal Airflow workflows or normal Argo workflows or normal step function state machines by default. And you do not have to sort of like now muck around with like, okay, what is Amazon state language or what is sort of like the Kubernetes manifest for writing an Argo workflow. You just write simple Pythonic workflow with very sort of like low cognitive overhead in terms of new concepts introduced, and then Metaflow will take care of all the compiling complexity behind the scenes for you. So yeah, so that was sort of like, a very, very high level overview of the functionality that Metaflow offers currently. So kind of like a very succinct version of Metaflow 101. I would now have Jacopo talk you through some of the functionality that we very recently released in the Metaflow universe that can give you sort of like a flavor of all the possibilities in the Metaflow universe. And then I'd be happy to sort of like take questions towards the end. Over to you, Jacopo.
Thanks, Savin. One thing, I think there's a question
So-
maybe in the Q&A if you want to answer it while I share my screen, maybe. I don't know if that's...
Yeah, I don't know if it was a relevant question. I saw that, but probably it's a generic question. Yeah, so we'd see. I think it's a generic question for significant computing engineering level. So I think we can continue with the presentation.
Okay, cool. Can you see my screen? Oh,
yes.
Did the switch work? Awesome. So thanks so much, Savin, for the great intro. I'm like
just
so
a second,
humble.
Jacopo. I think I'm still seeing the from DAGs to Dac Cards. Is that from Goyal? Is that your slide? That's the one,
Yes,
right?
yeah.
Okay.
We put it together in one thing, so when we share it afterwards, everybody is in one. Is gonna have one PDF. Yeah. So thanks so much. Like, I'm really humbled to be here. With an expert in, I mean, like a real world expert, like Savin in building a meta scale, and an expert in auditing and documentation like Tree. So hopefully this last part here will tie together kind of the expertise of both of you guys, and kind of tells the audience like a story of like how you can really improve the level of documentation and the level of kind of like awareness about what machine learning models and pipelines do with hopefully very little effort. So takeaway message from Savin. So first one, and I'm super happy and super proud of saying that we are Metaflow adopters, of course, and we've been Metaflow adopters for more than 18 months right now. And Metaflow literally changed our life as a productivity tool for our team. And one of the biggest lessons from Metaflow that you get, and we're going to go into that, but Savin was very clear already in showing the implementation, is that life in machine learning is basically a DAG. Meaning, is this graph of dependencies where you can specify a lot of steps, and all these steps kind of like go from, let's say your data to the final business, business outcome you want to achieve. And these steps have dependency between them. And you better understand how that works, when you go end to end. And Metaflow is kind of enforcing you, this best practices while you think about ML project through this very nice Python code. So what are Dac cards? Well, before telling you what Dac cards are, let's take a step back and go to the 2019 paper by Google about model cards that some of you, especially if you follow, again, free works on auditing, may already have seen. So this is a pretty famous paper by Google at that time, and they introduced this concept of model cards, some of which you can see here as an example. What is a model card? Model card is actually a fairly easy to grasp concept, not a very technical term. And it's this idea that since there's no central place in which you can explain what models do, not just in terms of precision, recall, and other pure quantitative KPIs, but also in terms of which type of product is better suited for the model, which type of unintended consequences we should look up for, which are the shortcomings that are known. So which are the cases in which you should totally not trust this model? So all of this, there was not like a coherent, somehow shared place in which you put all of the information. And so Margaret Mitchell and team kind of came up with this idea of model cards as this one-stop shop for model documentation. And the idea is that now, once you train a model, you have this, nice summary of what the model does. So what is the input? What is the output? What is the model KPI from a model machine learning point of view? And of course, again, what can be said about this model in a product context? So if you look at the actual example that they make in the paper or in the publicly available example from Google, you find something like this one, right? So a model card, as you see here, is this collection of important information about how this model is trained. In this case, a model that is trained to analyze toxicity in text. And just by looking at this, we can find some salient point about the original Google proposal. So first, it's focused on consumer application, as an application that, for which there's, not so much context to be understood before using that. Like another example that you find online is face detection. Like everybody knows what a face detection algorithm does, which is very different from the type of, enterprise application that, for example, I typically work with. Second, this card has been manually built by expert. As you can find, you can quickly realize by looking at the language, by looking at the references and the technical jargon. And third, this is all model and performance metric. If you see here, in fact, in the only charts that you find is about the quantitative, in this case, the AUC, so quantitative metrics of the model. There's no real notion about the data comes from, where the data comes from and how they get processed or deployed. And of course, it's very hard to reproduce these findings because these cards are for external use. Like these cards are thought for people to put on a public website. So necessarily, they don't give you access to the underlying artifacts that will actually allow you to run this model, okay? So it was a very, very pioneering idea, but it was, again, mostly tailored to, let's say, Google-like use cases, like global model deployed at scale, consumer first, and somehow for public consumption. But then, there's a rising trend that you probably have seen, with this, nice guy, Andrew Ang, of these new sort of AI use cases, right? Which are very, very different from the, Google consumer-centric ones. So, and this is the called data-centric AI. So data-centric AI is a bunch of techniques as idea, but the general feeling is that, especially thanks to pre-trained models and generally, the improvement that we make in machine learning, the performance is out of the box of models is actually pretty good. And the vast majority of your gain in terms of accuracy and in terms of business values are actually not in the models, which are getting commoditized, but actually is in the quality and quantity of your data, okay? So this is a very nice paper by Google, and it's like, while everybody thinks that ML is mostly about models, which may be true for, Google scale example that we had before, this is definitely not true inside of enterprises or even for, public model recommender system, but not at Netflix scale, right? So for example, Goyal is a B2B provider. We provide recommendation to all sorts of businesses. Some of them are very big, but some of them are not so big, and we still have to make them work. And in those cases, what you find is that data is as important, if not more important than the model itself. So when you go to school or when you do a tutorial online, this is what people tells you is about machine learning. Like you read data in, you train a model from, I don't know, Hugging Face or Scikit, and then you run some accuracy metrics, I don't know, hit rate K or MRR or whatever. But when you go in the real world, and Savin kind of gave you a glimpse of that already, which is exactly the things that Metaflow shine at, this is more likely something that happens in your pipeline. So you still read the data, but now you have to check the data. You have to prepare the data. You have to run additional tests that are not just precision-related tests. You have to deploy the model and monitor it, right? So there are way more steps that goes from the raw data to the final outcome, which is what you care about, what the business care about. And these are not really model-related. In fact, if you look at this pipeline here, the model is basically there just in two points. Like, when you train and when you deploy, everything else is sort of related to the model, but mostly related to the model and the interplay that it has with data. So these are the two trends that we sit, at the intersection of. One, data-centric AI tells you that data is super important. So when you want to document what you do, think again the model cards. Models are not necessarily the best focus of your analysis. Actually, what you really need to analyze is what happens before and after you train the model. So it's the entire pipeline. And then the second trend is, ML pipelines are basically DAG. Like ML pipelines are basically this long list of dependencies that has been orchestrated, for example, by a tool like Metaflow. If you combine all of this together, the result is that you don't have model cards anymore, but you have Dac Cards, okay? Which is a new version of model cards that kind of in spirit respect what the original model cards were doing, but adapted for a data-centric and Metaflow first world. So again, think about the standard like list of steps that you need to run. We really love Metaflow. We code everything up in in our Metaflow, and the idea is that once you run a Metaflow flow, we can get cards, we can get documentation like the one that Google send out, but we can get it almost automatically and with no additional effort. So what happens is that since cards are built automatically, I just want to be mindful of time, because I want to leave room for some question. But the cool idea about building cards in this documentation as a code kind of paradigm is that every time you run a Metaflow flow, you get a card that documents that specific flow in time. Remember what Savin was saying about Metaflow. You can always go back, you can always time travel to any point in the past and find out what happened in that specific moment. And now with Dac Cards, you can actually get the documentation in that specific moment. So there's no more remember to change Confluence or this kind of thing, because as long as you change your code correctly, your documentation is going to be updated all the time. Then, as a cultural thing, the idea that you need to instrument your code properly to have it documented kind of foster a culture of not saying this is a product manager job. Like the people that build the model need to make an effort to explain and test not just what the model does in the accuracy kind of thing, in the MRR kind of thing, the quantitative kind of thing, but they also need to be able to explain in plain English what are the strengths and the weaknesses and what they suggest the model to be tested on. Okay, we always joke about Game of Thrones. This is the equivalent of the Game of Thrones saying of like the man who passed the sentence should swing the sword. Like, so the man who builds the model should actually document it and explain it to others. There's no throwing stuff on the fence here. And finally, of course, cards are rectified themselves. Like cards are a subproduct of a normal Metaflow run. So if you follow what Savin just said, you of course can expect that cards are versioned and available to share for the eternity, basically, so that you can always go back and consult what the card you want to consult. So if you think about what a card actually looks like when you run with the card decorator, this is a real example. That the guys from other bands producing the documentation, you actually find out that with a simple code instrumentation or even no code instrumentation, if you just want a standard cards, you're gonna find this very, very nice. You see here, you're gonna find this very, very nice UI that kind of summarize, everything that there is to know about a card. I want to leave space for questions and kind of discuss, the philosophy a bit more. So I'm just gonna cut it here, as again, the slides are gonna be shared afterwards with a lot of links. So you guys are very welcome.
We can go over a few minutes if you want more time.
To go deeper in that. But so this is an example you see here on top. This is an example of a card that reports both, details about, what happens on the engineering side of it, but also you can actually plot stuff, like the plot that we really like to do as data scientists, and you can report that into a card, and then they can be saved and shared again with everybody in the company that does that. And if you're interested in a scholarly perspective, all of this, we from Goyal and a bunch of folks from other bands, we co-author a paper and Rips last year in the data-centric AI workshop, when we actually kind of tell the same story, but more from a more scholarly perspective, and kind of stress the importance of documentation also for good reproducibility practice in research. While it's true that both Metaflow and Dac Cards originated from people like Savin or myself that are mostly busy in building ML pipelines that scale in the world, there's also a huge community of research that actually can benefit and is actually already benefiting, for example, from Metaflow. Because Metaflow is actually pretty cool also when you write a paper or when you kind of benchmark different models. And we know that because we publish several papers with it, okay? And cards can kind of fulfill this problem in research of like keeping track of what you're doing while you run different experiments in kind of a seamless way. So even if you're using Metaflow just for research purposes or experimentation purposes, we really, really suggest you to check out the card decorator and the possibility of logging stuff and displaying stuff there, so that everybody in your team and everybody in your company can kind of discuss this. The idea of the card decorator is not to tell you what to store or what to save per se. That's your job. And again, and it's important that it is your job to understand how the model works enough to explain to others. The job of the card decorator and its philosophy is to provide you with a nice scaffolding and kind of a shared lexicon for everybody in the company to get together and kind of discuss these problems in a principled way, instead of having all these scattered tools like Confluence and Wiki and experiment tracking like all over the place. Cards are a way to put all of this together and put all the stakeholders in the same room. Thanks so much for your time. And of course, please check out Metaflow, which is really, really awesome. And if you have any question, on the documentation side, I'm super happy to answer them.
Perfect. Yeah, thank you so much, Savin, and thank you so much, Jacopo. I think this was a fantastic session. We packed a lot of information in a 45-minute session. I have a couple of questions, and if people have questions online, please use the chat window and please put them in so that we can get a discussion going. Now, first question, I think from Savin's perspective, you kind of mentioned, Netflix scale loads, wherein you have this whole process and you're automating things. Now, do you kind of see the place of Metaflow is primarily for, process automation kinds of tasks, or training and figuring out which model is the best model, or for both? Where do you see the place in the world for a tool like Metaflow?
Sure. So I think one point to sort of just go deeper into would be, what does Netflix scale? And I think on one end of the spectrum, Netflix scale could be all about Netflix recommendations. Mm-hmm. And on the other end, they are sort of like very mundane problems that people are trying to solve with machine learning as well. Like, one exciting use case here was that there was an engineer who wanted to predict how much time it will take to encode a video asset. And he wanted to sort of like just quickly throw together a model so that he knows that, should he be sort of like stepping away for taking coffee break or not?
Right.
But even when you're looking at sort of like, such smaller models per se, the amount of engineering and data science rigor that needs to go in, that sort of like proves a barrier that inhibits people from investing in data science for all of these use cases as well. So our purpose for Metaflow is that it essentially governs the entire life cycle of a machine learning project, all the way from how you are sort of like exploring your data, to training a model, to deploying that model in production, and dealing with all the errors, all the maintenance and ops concerns as well that would be involved. And at the same time, lower the barriers of introducing machine learning in a business context, so that, when sort of like as simple a problem as sort of like, figuring out how much time a video encoding job will take, people should sort of like feel comfortable that they can essentially invest in ML, and it would not sort of like yet again take them a quarter to build and deploy a model, and it can be something that can actually be handled in a matter of hours.
Mm-hmm. Interesting. And you mentioned Airflow and a couple of others. So you kind of see them as complementary products, or you see them as products which you would use in case you have specific kinds of use cases?
Yeah, I mean, I do sort of like, they are in many ways complementary to Metaflow. So people use Airflow, Prefect, Argo, step functions along with Metaflow. So these are sort of like production grade workflow orchestrators, and Metaflow is not sort of like replacing them, but Metaflow is essentially working with them. As a data scientist, you should not be expected to learn and understand the ins and outs of Kubernetes as well as Airflow. That's essentially our perspective, that you should be able to just like very simply write your workflows, and then we can execute those workflows on top of your favorite workflow orchestrator.
Okay, cool. And Jacopo, the use case you mentioned, how is Metaflow being used in Covio, if I may?
Sure.
In terms of
so our adoption started in the AI team, so in the team where I work on, and it was like a 10x productivity boost compared to our previous setup, which was made of a combination of non-ML purpose Python not orchestrator, but Python organizers, let's call it like way. Like if you know Luigi from Spotify, that's a good example. Or even, let's be honest, like horrible, like list of script that runs like one after the other to produce some table in LaTeX for for SIGAYAR, and that's kind of it. But it was a problem on so many ways. It was a problem to have reproducible research. It was a problem to go from them to even a prototype, not even a production model. And it was a problem because it kind of enforced people, it kind of invite people to be sloppy. And what I like about Metaflow is that it kind of invites you to be good by giving you a pleasurable Python experience. Like it's easy to do the right thing. which I think is the the high level value proposition of Metaflow. And
Mhm.
so when you think about this type of use case inside a company like Kobe, we just get public. So, it's not Netflix, but it's still, like almost 1,000 people, like it's still like a, $1 billion enterprise. Documenting the flows, it's super important with so many people and so many use cases and so many target organization, especially because some of our use cases are not so easy to understand. Like recommendation, everybody knows what recommendation are, either in Netflix or in any shop. But for example, I don't know, customer support, that's much more specific to the needs of the particular website you're deploying, what customer support is for, and so on and so forth. So there's a lot of context that you need to interpret a pipeline. And that's why the idea of model cards kind of falls short in these B2B use cases, because you need a bit more context. And what is the context for models? It's data. It's how data get acquired, it's how data get processed, and the feedback loop. And so kind of Metaflow kind of was a perfect marriage between this idea of like, well, we need to be better as B2B providers at documenting stuff, and then Metaflow that kind of makes us better at writing this tag. So I think it's the intersection of these two things that really came together. And when you guys tried out the new feature, let us know if we made a good job of actually design something that satisfies this. But for us, it certainly does.
Okay, cool. And what's kind of the roadmap for the Dac cards? Are you guys open sourcing it, or is it going to be built internally, or how do you kind of foresee the evolution of the product?
Yeah, it's already open source.
Yeah.
It's already,
okay.
Yes.
So so the Dac cards are also open source.
Yes.
Yeah.
Okay.
It's already part of the like the card decorator can already be used with the latest version of Metaflow.
Okay. And how about integrations with other platforms, or is it predominantly Metaflow specific? So
we started with Metaflow again because Metaflow kind of gets you a lot of this thing for free, like versioning, metadata, and so on and so forth. If somebody wants to integrate with other platform, I think we're super happy to kind of use what happened with Metaflow, which is what the paper in the RIP said. Like it can be think as a Northern Star, as a template of like, hey, if you have a data-centric tool like Metaflow, cards are helpful, and this is how you can implement it. So I think the implementation of Metaflow can be somehow a reference implementation for everybody that wants to use this philosophy somewhere else. On the Coveo side, if I may add, we release a library for recommendation testing in particular. It's called RecList. And a natural thing for us, which we will hopefully release soon, is a custom card, because Dac cards can be customized, is a custom card for people that are specialized in recommendation. So if you use Metaflow to build a recommendation and you want to use our testing tool, we can kind of marry the two and use the cards to visualize, what the testing library is doing. So I don't have an ATA for that, but in the next couple of months, we hope to release this kind of like extension so that people using Metaflow and recommender system can kind of find a new feature as well. Of course, completely open source as well.
Okay, cool. And how do you kind of see other users extending, beyond the either the Metaflow ecosystem or the RecList use case you mentioned? Is there like a interchangeable intermediary format which they can focus? Like I'm kind of taking an analogy of maybe Onyx, right? So if you want to think about like you're building in one platform, you're using in another platform, potentially you could use Onyx as an intermediary format and build upon it. One of the biggest challenges I've seen, in terms of auditing and also using is everybody is kind of, interested in optimizing for their use case. But when it comes down to using so many parts in the ecosystem, there are so many open source products. So you're now more or less doing glue sticks one to another. And then the goal was to build an extensible, flexible system, but you end up having a scaffolding of various products wherein you have many products evolving independently. And the weakest link kind of becomes like the point of failure for the entire system. So I'm kind of thinking loud in here, would there be an opportunity to put together an interchangeable format which can be, used by multiple systems, but also potentially extendable? That way you can interface with multiple systems, like what Savin was mentioning in his initial slide. You have RStudio, you have Jupyter, you have multiple other platforms. So I'm kind of thinking loud in here, is there an opportunity to build something like that?
Yeah, so I guess when it comes to sort of like these interchangeable data formats, they're also a function of business context. What could sort of like, work at a company which is predominantly R and is sort of like, focused on, let's say, dashboarding related use cases or hosting sort of like models as dashboards versus say, like think about like a Google scale sort of like ML problem that somebody would be solving. The requirements could be very different. And that's like precisely the reason why with sort of like Metaflow's architecture, we have remained fairly agnostic. If you want to sort of like overlay your own sort of like specific data format, Metaflow will work completely fine with that. If you just want to sort of like pass around normal Python objects, Metaflow sort of like works with that too. So it completely depends on the business context. So we would rather sort of like not be super prescriptive, because I completely agree that, in many organizations that sort of like becomes a critical need. But then for different organizations, those needs are going to be very different. And we do not want sort of like Metaflow to optimize for one specific use case at the detriment of sort of like many other use cases. The goal for us is to cater to as many diverse use cases as possible.
Perfect. Yeah. Thank you so much. I know we ran over a little bit, but I'm glad that we were able to put together this meeting together. I know we've been discussing online multiple times. Jacopo and Savin have visited my classes at Northeastern University and discussed and taught our students on enterprise systems. And I'm always very thankful for both of you for giving your time to share your knowledge and your experience with the audience. And as we mentioned, both the tools are open source. So if you can share your slides and also put in links on where to get the tutorials and also some use cases, but very much appreciated. We can share it with the audience. So next week, we will not have a session on Tuesday. It's the vacation week in here. So I have a couple of things planned with my family. But we are going to be meeting on Friday with Andrea Brennan from InQtel. And they went through a whole use case on bias detection, and they engaged multiple industry partners to actually do it. And she's going to be sharing their use case and also some of the information about machine learning assurance at 12 o'clock on Friday. So if you're interested, just go to www.quantuniversity.com and we'll have details about the upcoming sessions. And we will look forward to connect with you online. Thank you again, Jacopo. And
thanks to you. And thanks for the invitation. Thanks, guys, for attending.
So yeah, thank you so much. Take care. Bye-bye.
Thanks.